Welcome to Lab to Fab Insights, bringing you the latest on key issues shaping the future of semiconductor test and measurement. I'm your host, Paul Swangard, and I'm here with FormFactor's Jack DeGrave. He is a scientist in quantum application engineering and a cryogenic test and measurement specialist. And he's going to share his insights on the key trends, challenges, and solutions for testing semiconductors used in quantum computing applications. Welcome to the show, Jack.
Thanks, Paul. I'm glad to be here.
All right, let's get started. Quantum computing represents one of the hottest topics in computing and semiconductor technology. Industry luminaries have been quoted as saying quantum computing is at the forefront of national investment and initiatives in the race towards quantum supremacy. It's a race between countries and industry giants. And not only are there huge investments being made, there's a sense of urgency to make quantum computing a reality as it's seen as a performance alternative to traditional computing and the well-known limitations of Moore's Law. In many ways, quantum computing is seen as the solution to solving problems that are unsolvable by classical computers. So tell me how FormFactor has gotten involved in quantum computing and specifically testing of these new devices.
Well, FormFactor had traditionally offered cryogenic wafer test solutions, but in 2020, the company acquired High Precision Devices, or HPD. HPD complemented FormFactor's existing line of cryogenic wafer probe systems and cryogenic probes. The acquisition of HPD 2 years ago was the first step towards becoming involved in the quantum market. In June, another FormFactor acquisition, Janus ULT, dilution refrigerator products, made FFI the largest manufacturer of dilution refrigerators in the US. In addition, FormFactor recently announced the establishment of a cryogenic test service. This is a collaboration between HPD and Keysight, which should open up engagements from companies wanting to leverage our quantum resources. So we have certainly stepped up our involvement, and we're ready to help our customers as they engage in quantum computing development.
All right, so Jack, there's a lot to unpack there, and it sounds like FormFactor has made a tremendous investment and that you are playing a significant role in the quantum ecosystem.
We're playing a role in the quantum ecosystem. Think of it as a quantum computing stack. At the top, you have quantum algorithms, control software, control electronics for microwave signal processing. Then the next layer after that is the cryogenic hardware. This is the host system with feed-throughs and interconnects, which is where FormFactor comes in. We supply cryostats, probe sockets, dilution refrigerators, and cryogenic wafer probers, even photonic probing support. At the base of the stack is the device. This is a quantum processor, consisting typically of superconducting spin or photonic structures for the device.
So it sounds like FormFactor has assembled some very interesting components to your solution, but what is the rationale for the tool suite you put together?
Well, of course, we want to be able to solve the measurement issues. That's a given. But remember when I said that the companies are racing to come up with quantum testing solutions? It's all about accelerating quantum development. The engineers are challenged with long development cycles, complicated fabrication processes, with very few quality control checks. They must deal with time-consuming wire bonding and packaging for cryogenic test and measurement. We are enabling accelerated development by speeding up the time to data. As these quantum devices grow, the number of qubits, the fabrication process will need to be honed to avoid frequency crowding of the qubits and readout resonators. It will become increasingly important to collect statistical data sets at the wafer level, as well as measure devices in a millikelvin environment. FormFactor enables test and measurement throughout the quantum processor device fabrication process, whether it's testing resonators and junctions at less than 4 Kelvin, or at the wafer level, or performing final checks on the qubits in a sub 100 milliK or sub 20 millikelvin environment. We want to enable quantum developers to spend less time cycling dilution refrigerators and more time improving their designs and increasing the computing power of their quantum processors.
So Jack, what other kinds of test and measurement strategies can help accelerate the process?
First of all, you must remember that most of the testing requires a cryogenic environment. Plus, there is a huge amount of data that needs to be delivered. You'll need to devise strategies for each of the cryogenic elements of the quantum computer. You'll be dealing with cryo-CMOS, superconducting logic, as well as the quantum processor itself. These require high throughput for rapid probing. Working at the wafer level, our IQ3000 automated cryogenic wafer prober is the perfect environment for high quantum device testing, allowing for wafer probing down to 4 Kelvin. It can accommodate wafer sizes of 150 millimeter, 200 millimeter, or even 300 millimeters. It is fully automated, so you can rapidly step between die and sub-die. It can be outfitted with our cryogenic compatible RF probe cards for high throughput testing.
So much of the activity in quantum computing development has required millikelvin temperature conditions, requiring cryogenic equipment like you just described. And I understand there is another approach to development and testing that goes beyond electrical tests by including photonic elements. FormFactor is supporting that effort too. Tell me about it.
Yes. So far, we have been discussing superconducting and spin qubit devices. There has also been a great deal of progress made by photonic and ion or atomic qubits. As both paradigms move towards photonic integrated circuits, photon detection will occur on the chip via superconducting nanowire single photon detectors or transition edge sensors, both of which require cryogenic conditions. FormFactor offers the IQ2000 rapid chip scale prober for high throughput photonic probing that features automated fiber alignment and long travel range cryogenic nanopositioning for multiple die probing at less than 2 Kelvin. This allows developers to test the full functionality of their chip, whether they are injecting light with a surface grating or edge coupling feature. We are supporting customers no matter what development road they want to proceed down.
Quantum computing is certainly in its nascent stage, and companies are rushing towards the opportunity. But you hear names like IBM, Google, and others, huge companies that can afford to create the whole stack, as you referred to it. What about smaller companies that are pursuing a piece of the solution but are just not ready to invest in an environment that includes dilution refrigerators, cryostats, and cryogenic wafer probers?
FormFactor has developed a unique testing as a service offering for our quantum computing applications. And we did this specifically because access to capital equipment can be hard, both from a lead time as well as the overall investment perspective. And it takes time to set these things up. Sometimes there is no space, and most of the time there is nobody with the expertise on hand to set up and begin testing. So here we are again trying to accelerate development. We have cryogenic equipment such as the IQ3000 cryogenic wafer prober and millikelvin cryostats, as well as partners to provide an integrated test environment for quantum computing. Our test lab is in Boulder, Colorado, and we have engineering expertise in probing, cryogenic measurements, and we like to share that with the community. So instead of investing in training, customers can work with our staff to create a test plan and get going sooner rather than later. We know the markets are nascent and funding can be tight. So we believe our testing as a service is a great way to enter the market for early developers of quantum computing.
Well, Jack, you and the team at FormFactor have amassed a very comprehensive test solution for quantum computing. From dilution refrigerators, chip probing, cryogenic probe cards, automated cryogenic wafer probers, photonics probing, and test as a service, you have a vast array of solutions for anyone who wants to accelerate their quantum computing development. Really appreciate you sharing.
Yeah, it's been my pleasure. Quantum computing is a really exciting field to be involved in. It has so much potential for the advancement of applications like pharmaceuticals, cybersecurity, chemistry, artificial intelligence, and so much more. At FormFactor, we're really excited to enable the development of technology that will really change the world.